Okay, so starting with arrays, even before I get into this arrays, in previous sessions we were discussing about primitive data types, right?
I think
Can
we
anyone?
discussed about object and classes, sir.
It's
No,
host.
it's not exactly in previous session, not in the previous classes. I
Okay,
meant.
okay, sir.
Okay.
Yes, sir. Correct, correct.
So can anyone name a few primitive data types?
Integer, float, int, a float, double.
Okay, etc. etc. We have a few primitive data types. So similarly, we have a few other non-primitive data types, and of which we have arrays, strings. These are categorized under non-primitive because they actually were not evolved directly, but as a byproduct, I can say, or as an enhancement or something to add up to some primitive data type, we brought in non-primitive data types. So arrays and strings, both of them will be looking into them in our current session. Okay, so starting off with arrays, can anyone tell me what arrays mean, at least on a general definition? What
Arrays
arrays
are
mean? An English definition would be fine.
these are homogeneous set of elements, means same type of elements grouped together,
Good.
which have indexes.
Homogeneous. No, just a programming, just an English definition would be fine.
Yes, sir.
Arrays.
A homogeneous set of elements.
It's something like it holds some fixed amount of values inside.
Okay, those are all properties of an array. Well, yes, they're all right. But I just wanted one simple definition or simple, an English, a grammatical, at least a grammatical explanation of what an array means.
An orderly arrangement.
Collection
Order,
of items.
collection of items. Any more answers?
Hello,
Any more answers?
hello.
Hello. Hello.
Yes,
Yeah,
I
yeah.
can hear you.
Yeah. Any more answers?
An orderly arrangement.
Yeah, I can say that. Right? This is what a simple English definition says about what an array is, or it also says that it is an impressive display or a range of a particular type of thing. So it's homogeneous in nature. Now, similarly, we in programming also we have arrays where we can put in homogeneous set of elements, and these are fixed in size during compile time. Okay, and any element can be accessed in two ways. Any element can be accessed via an index, And well, going ahead, we have two ways of creating arrays, which we'll look into it when we start off with the program. Okay, so this is a simple explanation of what an array could mean. So now we'll look into different types of arrays. Okay. Okay. So we have two ways of creating arrays. One is through the literal way, and the other one is using new keyword. Okay, I'll show you how both the ways work. First of all, int simple. So now I have created an array of integers with the size 10. So what happens? There will be 10 blocks allocated sequentially in the memory to store 10 integers. Simple. There is another way of creating arrays as well. So here I would directly mention the elements of it. Now, based on the elements only, the length of this array is pre-calculated. Now, one more important thing about is that I can't manipulate the length of an array during runtime. Okay. So these are the two ways using which I can create an array. Now, similarly, well, I was mentioning you that any element can be accessed via an index. Okay, how do we do that? First of all, what I do here is I have an array of size 10. So what I do is I use a for loop. I just will say array of I is equal to what I'm going to, I'm actually doing 3 star I, that's it. Again, system.out.println. I just would print out 3 fine. Okay. So I've started an array. I've created an array, and after that, I'm just looping through this. I'm just looping through to set each and every element within this array, and then I'm just printing out the result using this. Now, whenever I say array of I and loop happens through this loop happens with this I as a looping variable. So I keeps changing. Similarly, the value of array of I also keeps changing. Okay. So, well, I don't think this is so much confusing. Is this fine,
Yes, sir.
guys?
Mm-hmm.
Yes, sir.
Deepak?
Fine.
Yes, I'm trying to figure out a few things.
Okay. I guess you have figured out already what yesterday's was.
Yes. If I have doubts, I'll get back to you because I need to watch the sessions 3-4 times in order to get the things right.
Okay, okay, fine, no problem. So similarly, I can navigate or traverse through any array using a loop, or I can directly access an element. I can directly access any element of an array with the indices mentioned like this. And sorry, usually our indices starts with 0. So my first element would be 2. Clear? So this is one more important feature of an array where I have dynamic access. Okay, so this is with arrays, and so far whatever I have explained to you was single dimension array, where my arrays can grow or shrink in one direction only, right? Now similarly I can have arrays in multiple dimensions. Okay, we just have considered 2 dimensions because going any more further would make your own program complicated and unreadable to you itself. So I'll just take up a 2-dimensional array where I mention a simple example for this would be our matrices. Are everyone aware of matrices?
Yes.
Ma-
Yeah, Pawan.
Yes,
Deepak,
sir.
Yes.
matrices aware
Yes.
of this? Yeah,
Yes.
that's good.
Better than bottles. Anything better than bottles.
Sorry?
Anything better than bottles.
Okay. So our 2-dimensional array would nothing but depicting a matrix actually. So a matrices of n cross m. What do we say here? So the same dimensions which we can mention here. So similarly, for traversing through a 2-dimensional arrays, I need, how do I traverse?
Using two variables.
Yes. Okay, instead of this, I'll make this string so that. Okay, so I just will do Okay. So similarly, I can traverse through any two-dimension array like this. Okay. Clear with two-dimensional arrays.
Yes, sir.
Okay. So our next concept would be our object-oriented programming concepts, which is our encapsulation and abstraction. Okay, I'll create a simple other class. So okay, let me not create this. Okay, I've just created an animal class. Okay, now getting on to encapsulation, I'll pick up each and every topic separately. Okay, so can anyone tell me a simple meaning of what encapsulation means?
Wrapping up of data.
Wrapping up of data. Any other thing? Any other answers?
Like sorting.
Encaps encapsulate. Any other definition? Binding together, right?
Okay.
Okay.
Yes.
This is what encapsulate means, right? Binding together something. Now, in our object-oriented programming also, we need this encapsulation. Where do we need this encapsulation? Where we actually bind the attributes and actions together. Simple. So, for example, I have an animal class. Okay. So, I am actually mentioning certain attributes. Can anyone tell me a few attributes of an animal?
Size,
Wait.
weight, size.
Size, can I quantify it?
No, sir. Height,
Type of
Then species,
gender,
gender, color. Someone telling color now.
religion,
Okay, let's not go further into it. A few actions: eat, sleep, walk, etc., etc. Now, yeah. So similarly, we bind all these attributes. I'll take the same there. Public and Fine. So we have 4 attributes for an animal class, an animal here. And as we were seeing, we had a few actions which animal performs. So I'm just printing out. So a few actions I have given here. So what happens when I'm actually creating an animal instance? For example, I'll say animal dog. Continue. Animal. So whenever I say this, an object dog is created, and what does this instance have?
So weight, height, species, gender.
Yes, this instance will have all the attributes, and actions, coming to actions, actions will be performed as if these actions were bound together with the object itself, right? For example, I say dog dot perform it. Now this method is acting as if this is actually bound to dog, right? So this is where I say that we are actually encapsulating attributes and actions together. Fine. So this is one important thing in object-oriented programming, because any object which actually needs its identity need to have both attributes and actions, right? So that is why this is the foundation concept, I can say, in case of object-oriented programming. Well, there are other concepts which get built on top of this. We'll see through that in our later sessions. Okay, so encapsulation just means that we are binding the attributes and actions together, and it is behaving as if both of these attributes and actions are particularly meant for this dog object.
And
Fine?
the question here,
Yeah.
it's just a general in terms like as you're trying to explain, every term has its attributes and action, right?
Mhm.
So each and every term needs to have. Is it a mandatory option? Because in Java, it needs to have these things for every every terms.
No. What happens is, like, for example, I am actually giving you simple examples so that you can understand. But in real world programming, means in real time programming, you will not create animal objects, right? You'll be actually working on something, some other concepts where you will not have all these attributes and actions in mandatory.
Okay.
Right? So probably there will be some classes which will be built only for the sake of metadatas. Like, for example, I'll have certain classes which will be like carrying only metadatas, like for example, only attributes. Okay. So it is not, I'm just giving you one simple class with an example, but when it comes to a real-time projects, it's not one simple class, right? It's a combination of classes.
Uh-huh.
So in such cases, it is just one class will not have a role to play, where a different design patterns will be applied, and different design patterns will be applied, and accordingly, each and every class in that design pattern or in that UML will have its own importance.
Okay.
Okay. So it is not mandatory that we have all these attributes and actions defined for every class. Okay. There will be certain classes for which I don't have any attributes. There will be certain classes for which I don't have any actions.
Okay.
Okay.
Mm-hmm.
So this was with our encapsulation. Now moving on to our next topic, which is abstraction. Okay. So can anyone tell me a general definition of what abstraction means?
It's like difference.
Difference means a difference in what?
Abstract. It's a unique thing.
Unique? Nope. What abstraction means? Anyone else?
Hiding the implementation details.
Okay,
Extracting
hi.
common features, मतलब extracting
Okay,
common
all these
features.
are programming answers. Yes, they are true, but abstraction, a general answer I need. What abstraction means?
We dealing with ideas.
Okay, I'll not take this too far because I start getting so many answers as if I'm searching on Google. Okay, abstraction in a simple terms means that I'm actually hiding a few details and showing a few. Okay, I'm not hiding completely, I'm not showing completely, but I'm abstracting it. So why is abstraction needed? Can anyone tell me? Why is abstraction needed?
So for simplicity or for security purpose, maybe.
Yes, I agree with this. Simplicity, security. Okay, all these reasons are true. Well, I'll take up one simple example to show how this abstraction is important in case of object-oriented programming. Okay, consider I have a car. Car, fine. So I have a car I have a car. Now, a car will have so many different attributes and actions, right? Okay, let me not bring it to this attributes and actions level again, so that get confused. Okay, can anyone tell me what are all actions which are happening within a car? Right. For example, first of all, my fuel is pumped into the engine. Then spark plug is ignited. Then in turn,
Combusted.
fuel is ignited, combusted, and random expansion leading. Can you please go on mute? I can hear a lot of noise. Okay, and random expansion leading to movement of piston, and this motion is transferred to linear motion and leading the car to drive on the road. Okay, can you tell me, is the driver ready to maintain all these details? Is the driver ready to look into all these details when he is driving the car?
No.
Or is the driver, or do I need to show all these details to the driver while he's driving?
No, sir.
Others awake? Hello,
Hello.
Sarvesh,
Yeah, Pawan.
Pritam, Aditya.
Yeah, Pawan.
Yeah. Okay. So coming back, does the driver need to know all these details while he is driving a car?
No.
No.
These are
Yeah.
the internal workings of a car.
Yes, exactly. So actually, the driver doesn't need to know all these details while he's driving a car. He just needs to know what he needs to, like for example, a car general in general, what will it have? A steering wheel, right? A steering wheel and my ABC pedals and my gear knob,
Arun,
dashboard. Yeah,
sorry to
hi.
intervene. My net connection got disconnected. So, if it's possible, can we start from just 5 minutes back? Because was not able to get access for the screen.
Okay.
Just
Uh,
just started
yeah,
you.
yeah. Can you please go on mute?
Okay.
Yeah. I was actually mentioning about abstraction. I'll not go much deeper into it. I'll just hover over it. Okay, so I was mentioning that abstraction is also another concept in object-oriented programming where actually we hide a few details and we show another few details. Main reason for having abstraction in our programs is to make it simple and secure. Okay, so I was giving an example of a car where when I'm actually driving, there are a few actions which are happening within, like, for example, first of all, my fuel gets pumped into the engine, and then a spark plug ignites the fuel, which leads to combustion of fuel, and the random expansion of this combustion leading to my movement of piston, and this movement of piston is again transferred into linear motion, which leads my car to drive, right? So all these details are happening within the car, and does the driver need to know whether does the driver need to know all these details while he's driving the car?
No, it's
No.
internal details for the car.
Exactly. So it's internal, and the driver doesn't need to know. Means it's not required for the driver to know all these details, so that he if he wishes to drive a car. Okay. So because of that, all these internal details are taken care, and the only few details which are given out to the user are these details. That's it. There will be
Okay.
there will be a steering wheel provided to him, and there will be all these pedals and their gear knobs, and there is a dashboard to show you what are all the details, like for example your speed and whatever your fuel levels and all. Okay, so and you can see this abstraction evolving much and more day by day. Nowadays there are other few cars, like for example you might have noticed Google has cars, right? These cars, they're all working on you. For example, they're all working on voice over instructions. Can anyone remember this? There are a few cars which are built for which you just have to say out where you need to go.
Still, it is not allowed in India, sir.
Yeah, it's not allowed in India, but this technology has already evolved.
Yes, sir. Mostly, I think in BMW it is there, sir.
Yeah, it's in BMW. It's in there, but I guess it's not totally automatic.
Yes, sir. It's not totally automatic. If I
But
want to receive the phone, then
but Google cars are, as I was noticing, that user has to just say out where he needs to go, and the current location is picked up based on GPS, and then the route is framed, and the car is driven in that way, right? So this is another level of abstraction led from this one, okay, where all these details in turn are taken care by various sensors, various navigators, and all are much more evolved to make this abstraction even more better. Deepak, I guess he's again disconnected. Okay, so is this clear to everyone?
yes, sir.
Yes, Pawan.
Okay. So abstraction actually can evolve to any such extent, but ultimately our basic purpose will not lose its meaning. That's it. It has to make abstraction ultimately has to make any feature simple and secure. That's it. So this was with abstraction, and moving on to our next one is an example with encapsulation, which we saw already. Now we have strings, string buffers, and string builders. Okay. So coming to strings, strings are again non-primitive data types. Okay. Strings again are non-primitive data types. Well, we were using strings so far to store any series of characters within it. Similarly, I have strings where I can store a series of characters. Okay. Now, coming to a ways of creating string, well, I'll create another class. Okay. I have again two ways of creating string. Like in arrays, I have literal way and another way using my new keyword. Okay. A literal way is simple. String str is equal to first string okay. This is my literal way. I'll actually differentiate in terms of memory allocation in literal way and new keyword once I give you out this difference between new and literal way. String, another string is equal to new string. I'll say another string.
Seems like Aditya, please go on mute.
Aditya. Okay. So proceeding further, I have okay. So this is my literal way of creating a string where I just directly mention that my str is a string and assign the value of it directly. And another way using my new keyword is that I actually have the syntax like this, where actually the value of another string would be another string. Okay. So now how are these both different from each other? Well, in terms of memory allocation, they make a difference. I'll bring up Paint. Okay, as and when my program is loaded onto my virtual machine, I have these two types of memory created. First is my heap. Well, I'll increase the font size. Okay, this is my heap memory. Okay, and oops, this is not my heap memory. This would be my okay. This is my stack, and this is my heap memory. So what happens in case of literal way of creating a string? Okay, so well, as soon as my runtime sees that string str is equal to another string, first of all, right, and I have str. So yeah, so this will be like this. Now what happens is that whenever I create any string through a literal way, like for example, I have done here str is equal to first string. Now again, if I'm going to change like this, string str is equal to new, I'll say different string. Now what happens in this case is that first of all, my runtime looks for any other object on the heap, any other string object on the heap, which has the same value different string. Okay. It finds that there is another object on the heap whose value is different string. What it does is it just removes this connection and gets connected with this. Okay, if it doesn't find any other object, string object, it just creates one and stores the value into it. Now what happens if another string I create using a literal way, say I have created another string str1, okay, whose value is different string. What happens? It again starts pointing to the same object. Okay. Now when I change str1 dot, I actually change the value of str1 to some other string. Now it again disconnects from this string and looks for the new values on the heap. If it finds, it will point to that object. Otherwise, it will create a new object. Okay. So this is how a literal way is followed. Now, how is my new keyword different from my literal way? In case I am actually creating a string using my new keyword, what happens is that because this new keyword comes into picture, there is a separate memory allocated each and every time. It is not that it will look for some existing memory object with the same value. It will actually create a new object where it will store this another string data and give its reference to another string. That's it. It will not go into finding out existing objects and pointing it to them, then again disconnecting and all. Fine. This
Means,
is
sir, every time it will create another different string and then point it out.
no. I mean to say, whenever I use this new keyword, whenever I use a new keyword, then only it will create a new object on the heap.
Okay, sir. Okay.
Okay. So this is the main difference between having a literal way and using new keyword. Okay. So in any case, well, I'm creating a string now. Okay. So consider I have this string. So I have a string like this. Now, say I am actually in need of joining this string. So what I do is I'll actually concat this string with data at the end. Concat is nothing but joining str with this data. Okay. Ultimately, what it should show is my first string data is my intention of get is my intention. But what happens in this case is that, like for example, I'll just print out oops. Can anyone notice that even though I have concatenated it, I'm actually still getting first string,
Yes,
right?
yes, sir. You are.
The string str value remains the same. We have not passed the value to str.
I've already passed the value, right? I've set the value of str.
That is first string. After concatenation, we haven't passed it to str. That's what it is.
Exactly. So what happens in this case is that whenever it finds this instruction, it will actually create a new memory space. Okay. So it will actually create, it will actually create a new memory space. Okay. And it will concatenate it also. Say first string data. It will create a space and it will concatenate also. But since we are not giving it back to any other reference, it remains like this. It will not be given back to anyone. Now, when I actually find that, can you notice this? The change which has happened?
Yes, sir.
After concatenating, I have to give the reference back to my string so that whenever I reuse the string again after that, I'll actually get the updated value. Okay. So this is the main reason. And well, this is one more property of a string where I say that strings are immutable. They are immutable in nature. Immutable means it is, they are like unchangeable on their own. Okay. So to overcome this feature, actually, there were string builders, string buffers which are brought into picture. Okay. So now how string buffers help me? First of all, to overcome immutability, string buffers were made mutable, first of all. Okay. So how string buffers were made mutable? I'll just take up a simple example. String buffer sb1 is equal to, I'll say same Instead of first, I'll use second. So in case of string buffers, I actually don't have concat, I actually have append. So what I do is, fine. I'll remove this part. Find the difference? Where string buffers are capable of changing on their own. That is why string buffers were made mutable in nature. Okay, so that is the main difference between having strings and string buffers, where string buffers on another note were actually made. One more important added feature of string buffers were that they were made thread safe. Thread safe in the sense, well, we'll discuss this when we are talking about multitasking. Okay, so they were made thread safe so that multiple processes running parallelly, even if trying to modify a string buffer, it maintains synchronization between all the threads. Okay, so they were made thread safe, and they were comparably faster than strings. Okay, so but they were comparably faster than strings. Now there was one more drawback in having the string buffers, right? So for simple usage where I don't need all this thread safety and all, even then there was a little delay when actually string buffers were trying to maintain thread synchronization. So there were string builders brought into picture. Now what these string builders again are, mutable in nature, which was the basic drawback with strings. So that was again overcome by string builders. Now string builders are not thread safe. So because of removing this thread safety feature from string buffers, these are faster than string buffers. Clear? So again, string.
Sir, are all the methods one and the same in string buffer and string builder?
Mostly.
Okay.
Because I don't have all this thread safety uh, related parameters to be maintained in string builders, right? So those doesn't come into picture at all. Okay, again it's the same way. Okay, so that mutability is actually carried over to string buffers and string builders. Fine. So this was the main difference between having string buffers and string builders. Okay, so as per the need, we can use whichever we want. That's it. Fine. Deepak.
Yes, sir.
Yes, I'm here.
Okay.
Actually,
I guess.
my net got disconnected, so I got
Yeah. Yes,
the
I
session.
can see that.
So So it took me 2-3 minutes to get back onto the network. So I'll watch the video. I need to watch the video again because I missed out around the things after the car example.
Okay, no problem. So this was with my string buffers and string builders. Okay, so we have other few topics which I'll take up in the next session. So go through this session again. If you find any doubts, you can get back to me. Okay.
Okay.
Yes, sure.
Okay. So in that case, we'll
Sir, hello.
yeah.
Sir, so in string buffer, it is thread safe. So, sir, the only simple string primitive data type is not thread safe, sir.
Nope.
Okay, it's sometimes may get means corrupted when we are using current concatenating or other operations while using multi-threading. Is that so, sir?
No. It is not just with concatenation. It is with
Then
basic other string operations. Like for example, if I'm changing the value of string,
yes, sir.
when there are actually multiple threads which are running, so
Mhm.
I cannot have this basic string to actually maintain synchronization between multiple parallel threads running. Okay.
Okay, sir.
So
Okay,
in
okay.
that case, string buffers are useful, but because this thread safety concept comes into picture in case of string buffers, even if I'm using for a simple general use, they actually mean a little costly. So that is why string builders were brought in with just mutable feature.
Okay, sir. Okay, okay. Thank you, sir.
Okay. Okay. So again, we'll reconvene next week.
Okay.
Okay. Okay, guys.
Yes.
See you all.
Thanks
See you,
for
sir.
Bye.
Bye.
Bye.